The purpose of a ground fault safety check is to determine that an inverter's ground fault detection hardware properly detects and indicates that its overcurrent protection breaker is in the open tripped state. A byproduct of this safety check also verifies there is no external fault between the normally grounded array conductors in the PV array and the system ground bus. This is otherwise known as the blind side ground fault. Should an inverter fail this important safety check, the entire system should not be worked on until the problem has been corrected and this check can be successfully completed. Because lethal DC and AC energy potentials exist inside the inverter with the inverter service disconnect switches in the open or closed positions, this safety check should only be performed by electrically qualified service personnel outfitted with proper personal protective equipment. This presentation will demonstrate how to perform this check on the SGI series of inverters. It's the 225 through 500 kilowatt models with the LCD display and LEDs functional, and another short demonstration at the end when the LEDs and the LCD display are not functional. Okay, so before we can start the ground fault safety check, we have to stop the inverter from exporting power to the grid. To do this, press and hold the escape key on the touchpad for about 4 to 5 seconds. Here, the contactor open, and the inverter is no longer exporting current to the grid. Next, we're going to open the inverter's DC service disconnect switch. Then we're going to open up the inverter's AC service disconnect switch. Wait for the indicator LEDs and the display to go cold, dark, and dead, and now they are. Open the enclosure doors. Locate the GFDI breaker, which is on the rear wall of the enclosure, and set it to its open tripped position. Close the inverter enclosure doors. Close the inverter's DC service disconnect switch. Close the AC service disconnect switch. Okay, so now we've verified that the ground fault LED is illuminated. This is what the inverter is supposed to do. If the inverter fails to do this, then it fails this safety check and no further work on the system should be performed until this condition is corrected and the ground fault LED illuminates as it is supposed to. Open the inverter DC service disconnect switch. Open the inverter AC service disconnect switch. Wait for the indicator LEDs to go cold, dark, and dead. And they are. Open the enclosure door. On the rear of the inverter, and close the GFDI breaker. Close the enclosure door. And the test is completed. All right. In cases where the indicator LEDs on the inverter are non-functional, we then have to verify the safety electrically using a digital multimeter set to measure DC volts. We've already pre-set up the digital multimeter in this inverter. It is connected between the system ground bus and the normally grounded array bus over on the left side of the main enclosure. Okay, so what we should see with the breaker in its closed reset position is 0 volts DC on the multimeter, and we do. If we open the breaker, we should see a DC voltage on the digital multimeter. We don't care what the magnitude of that voltage is, just that it's there, and it is. Go ahead and close the GFDI breaker, and the voltage should then go back to 0 volts DC. This is what the inverter is supposed to do. If the inverter fails to do this, then it fails the safety check and no further work on the system should be performed until the condition is corrected. Okay, so at this point we can go ahead and close the inverter up and the test is complete. Now, while this does not confirm that the detection circuit in the inverter is functional, it does confirm there are no faults in the array wiring that the inverter can otherwise be serviced without risk of DC electric shock. That's the end of the presentation.